We are the group 4 and we are assigned to answer the exercises 6.2 items number 3, 11, 19, 27, and 35.
Hi, I am Vanessa Mateo of BSED Math 3A and I am assigned to item number 19 of this chapter, the applications of the normal distribution.
Glenda Postrado from BS Ed Math 3A, assigned in number 27.
Good day, everyone. I am Carla Joyce Puno from the BSED Math 3A. And I am assigned to answer the number 3 and 35 on the Chapter 6, Exercises 6.2, Advanced Statistics.
Good day everyone, my name is Ella Jane H. Timbang from BS Ed Math 3A and I'm assigned to do the exercises 6.2 item number 11.
I am Carla Joyce Puno and I will show you how I solved Chapter 6, Exercises 6.2, number 3. This is our given problem. Population in U.S. jails. The average daily jail population in the United States is 706,242. If the distribution is normal and the standard deviation is 52,145, find the probability that on a randomly selected day, the jail population is A. Greater than 750,000 and B. Between 600,000 and 700,000. And we have our general given, which is the mean population, our average jail population or population mean 706,242 and standard deviation 52,145. And now we proceed on our letter A, greater than 750,000. We have our given. Our population mean is 706,242, standard deviation 52,145, and our x from our given A, 750,000, and our probability, the z, which is the missing one. So step 1, we draw our normal distribution curve and we plot our population mean, which is the 706,242, and we plot our x value, which is the 750,000, approximately there, and it states that greater than 750,000. So our area to be found is on the right side on the 750,000. And next we calculate. We use the formula for z value. This is our formula and we substitute our given values. We have 750,000 minus 706,242 all over 52,145. And then we subtract. We have 43,758 over 52,145. And now we divide. Now we have 0.83916 and we go for the 2 decimal places, so we round off. And now we have 0.84. And now we look at the table for its corresponding value. This is the table for cumulative standard normal distribution. And we are looking for the 0.84. There, the corresponding value of 0.84 is 0.7995. We go back on our problem. We have z equals 0.84 and its corresponding value based on our table, it's 0.7995. The 0.84 is the 750,000 on our curve. And we find the desired probability. We have probability of x greater than 750,000 equals probability of z value greater than 0.84 equals 1.000 minus 0.7995. We subtract our value 0.7995 with 1.000 since the area that we are looking for is on the right side of our x value, which is the 750,000. And the 1.000, it is the whole area of our curve. So we subtract. We now have 0.2005, and then we round it off. We have 0.201, and we multiplied it by 100, so we get its percentage. We have 20.1%. Therefore, the probability that on a randomly selected day, the jail population is greater than 750,000 is 20.1%. And now we move on our letter B, between 600,000 and 700,000. We have our given population mean 706,242. Our standard deviation 52,145. And for our x value, we have 2. We have x sub 1 and x sub 2. For x sub 1, we have 600,000, and for x sub 2, we have 700,000. And our probability, which is z, which is what we are looking for. So, for step 1, we draw our normal distribution curve. And then we plot our mean, which is 706,242. And next, we plot our two value of x. We have 700,000 and 600,000. And the area that we are looking for is between the 600,000 and 700,000. So, step 2, we solve. We use the formula for z value. We have this formula, and first, we solve for our x sub 1, which is the 600,000. Then we substitute our values. We have 600,000 minus 706,242 all over 52,145. And then we subtract. We now have negative 106,242 over 52,145. And then we divide. And now we have negative 2.0374. And we get the two decimal places. We have now negative 2.04. And now we look at the table for its corresponding value. This is our table for cumulative standard normal distribution. And we are looking for negative 2.04. There. And its corresponding value is 0.0207. And now we have z equals negative 2.04, and its corresponding value is 0.0207. And this is the value of z for our x sub 1. And now we are going to solve for our x sub 2, which is the 700,000. And now we substitute our values. We have 700,000 minus 706,242 all over 52,145. We subtract, and now we have negative 6,242 over 52,145. And then we divide. And now we have negative 0.1197. And then we look for its two decimal places. We round off. We now have negative 0.12. And now we look at the table for its corresponding value. This is our table for cumulative standard normal distribution. And we are looking for negative 0.12. There. And its corresponding value is 0.4522. And now we have z equals negative 0.12, and its corresponding value is 0.4522. And this value of z is for our x sub 2. And now we combine the corresponding values of our x sub 1 and x sub 2. We have z equals negative 2.04 and its corresponding value is 0.0207. This is the z value for x sub 1. And we have z equals negative 0.12. Its corresponding value is 0.4522. And this value of z is for our x sub 2. And now we find the desired probability. Our probability of x is x greater than 600,000 but less than 700,000. And this is equal to probability of z greater than negative 2.04 but less than negative 0.12. And this is equal to 0.4522 minus 0.0207. The values of our z value for our x sub 1 and x sub 2, we subtract them. And now we have 0.4315. And we multiply it by 100, so we get its percentage. And now we have 43.15%. Therefore, the probability that on a randomly selected day, the jail population is between 600,000 and 700,000 is 43.15%. Thank you for listening.
Exercises 6.2, item number 11. For item number 11, we have the average credit card debt for college seniors is $3,262. If the debt is normally distributed with a standard deviation of $1,100, find these probabilities. First, that senior owes at least $1,000. That senior owes more than $4,000. And that senior owes between $3,000 and $4,000. For the item number 11, we have the average credit card debt for college seniors is $3,262. If the debt is normally distributed with a standard deviation of $1,100, find these probabilities. So we have the mean is equal to 3,262 and a standard deviation of 1,100. We have to find that senior owes at least $1,000. So our x will be 1,000. We will use the formula for the standard score, which is z is equal to x minus mean divided by standard deviation. Substitute the given. We have 1,000 minus 3,262 divided by 1,100. Then we have negative 2,262 divided by 1,100. And z is equal to negative 2.06. So, on the distribution curve, since we're looking for the senior owes at least $1,000 and the z value and z is equal to negative 2.06, then the part will be at least negative 2.06, then the shaded part on the right. And based on the procedure table, finding the area and the standard normal distribution curve, to the right, if The next, we have to find the probability that senior is more than $4,000. We have the given mean is equal to 3,262 and standard deviation of 1,100. Their x will be 4,000. Use the formula for the standard score. We have z is equal to x minus the mean divided by standard deviation. Then substitute the given 4,000 minus 3,262 divided by 1,100. We have 738, 1,100. Then divided 8, we have the z is equal to 0.67. And for the normal distribution curve, since we're looking for the probability that senior owes more than $4,000, the shaded part will be on the right of 0.67. Also, based on the procedure table on finding the area under the standard normal distribution curve. So we have to look up the z value and subtract the area from 1. So for the probability of any z value greater than 0.67 is equal to 1 minus the probability of any z value less than 0.67. Let's find the area. So for the 0.67, we have 0.7486. We have to subtract the area from 1. So 1 minus 0.7486, we have 0.2514 or 25.14%. So for the probability of any z value greater than 0.67, we have 25.14%. Then last, we have to find the probability that senior owes between $3,000 and $4,000. So we have the given mean is equal to 3,262 and the standard deviation of 1,100. So we will use the two values, which is 3,000 and 4,000. Z is equal to x minus the mean divided by the standard deviation is equal to 3,000 minus 3,262 divided by 1,100. We have negative 262 divided by 1,100. Then z is equal to negative 0.24. Then for the value 4,000, z is equal to x minus the mean divided by standard deviation. So we have 4,000 minus 3,262 divided by 1,100. We have 738 divided by 1,100. Then z is equal to 0.67. Then for the normal distribution curve, since we're looking for the probability between $3,000 and $4,000, the shaded part will be in the between of negative 0.24 and 0.67. Based on the procedure table and finding the area under the standard normal distribution curve between any two z values, we have to look up both z values and subtract the corresponding areas. So for the probability of any z value between negative 0.24 and 0.67 is equal to the probability of any z value than 0.67 minus the probability of any z value less than negative 0.24. We have to find the area of 0.24. We have 0.4052. And for the area of 0.67, we have 0.7486. Then subtract the two areas. 0.7486 minus 0.4052, we have 0.3434 or 34.34%. So for the probability of any z value between negative 0.24 and 0.67, we have 34.34%. And that would be all. Thank you.
For item number 19, the given problem is a contractor decided to build homes that will include the middle 80% of the market. If the average size of the homes built is 1,810 square feet, find the maximum and minimum sizes of the homes the contractor should build. Assume that the standard deviation is 92 square feet and the variable is normally distributed. Since the variable is normally distributed, then the cutoff points and shaded area are shown as this figure, with a given mean as 1,810 square feet. The shaded area is the middle 80%. 40% lies below the mean, and 40% lies above the mean. That means that the remaining unshaded area will have a total of 20%, 10% below the minimum size and 10% above the maximum size of the homes. Now, this figure shows that two values are needed: the minimum and maximum sizes of the homes the contractor should build. To get the area to the left of the positive C value, we have to add the 50% of the total area below the mean and the area between the mean and the positive C value, which is 40%. So 50% plus 40% is 90%, which is equal to 0.9000. Now let us use the table E to look for the closest C value to 0.9000. It is not in this table, but this area, 0.8997, is much closer to 0.9000, and the closest Z value to 0.9000 is 1.28. Now let us find the maximum value using this formula, and just plug in the corresponding values for the C value, standard deviation, and the mean. So we have x sub 1 is equal to 1.28 times 92 plus 1,810. With the use of our calculator, our x sub 1 will be equal to 1,927.76. We now have the maximum size of the homes the contractor should build. Next, let us proceed to finding the minimum value. Going back to this figure, the area to the left of the negative C value is 10% or 0.1000. Again, with the use of the table E, let us look for the closest C value to 0.1000. It is not also in the table, but this area, 0.1003, is much closer to 0.1000. So the closest C value to 0.10000 is negative 1.28. Now let us find the minimum value using this formula again, and just plug in the corresponding values. So we have the product of negative 1.28 and 92 plus 1,810. And with the use of our calculator, our x sub 2 is equal to 1,692.24. We now have the minimum size of the homes the contractor should build. Therefore, to include the 80% of the market, the contractor should build homes with a size of more than 1,692.24 square feet but not exceeding 1,927.76 square feet.
Number 27. Product Marketing. An advertising company plans to market a product to low-income families. A study states that for a particular area, the average income per family is $24,596 and the standard deviation is $6,256. If the company plans to target the bottom 18% of the families based on income, find the cutoff income. Assume the variable is normally distributed. So we have the given average or mean, standard deviation, and the bottom 18%. So let us draw first a normal distribution. Let us plot the mean $24,596 and the bottom 18% or 0.8. Why is it on the left side? It is so because the problem states bottom 18%. So we have here the missing value. To find the missing value, let us first look for the z-value of the area 0.18 on the table. So I tried searching for 0.18 or 0.1800 in the table, but I cannot find it. And based on what I have learned, if the specific value cannot be found, we should use the closest value. And the closest value in 0.18 on the table is 0.1788. So we are going to use it. Then we will find its z value. So column first, which is negative 0.9, and then row, which is 0.02. Then we're just going to add them, which is equal to negative 0.92. So we have now the given mean, which is $24,596, standard deviation, which is equal to $6,256, and the z-value is negative 0.92. Next is, we are going to use the formula z is equal to value minus mean over standard deviation. So this formula used to transform the original variable into standard normal distribution variable. So we have negative 0.92, which is the z-value, equals x minus $24,596, which is the mean, over $6,256, which is the standard deviation. So in this case, we are looking for x. Let us perform cross multiplication. So we will have negative 0.92 multiplied by $6,256 equals x minus $24,596. And then negative 0.92 multiplied by $6,256 is equal to negative $5,755.52 equals x minus $24,596. And then to leave x alone on the right side, we're going to add $24,596 on both sides. So it will be cancelled. And now we only have negative $5,755.52 plus $24,596, which is equal to $18,840.48. So this is the value of x. However, we can also use the formula x is equal to z-value multiplied by standard deviation plus mean to find the value of x easier. So we have the given mean, standard deviation, and z-value. Then we're going to substitute, and we will have x is equal to negative 0.92 multiplied by $6,256 plus $24,596. So, negative 0.92 multiplied by $6,256 is equal to negative $5,755.52 plus $24,596, which is the mean, and it is equal to $18,840.48, which is the same. So, an income of $18,840.48 should be used as a cutoff. Any family that earns $18,840.48 and below is qualified.
I am Carla Joyce Puno, and I will show you how I answered Chapter 6, Exercises 6.2, number 35. Our given problem: in a normal distribution, find standard deviation when population mean is 110 and 2.87% of the area lies to the right of 112. Our given population mean 110, our x value is 112, and our z value is 2.87%, and we are looking for our standard deviation. Step 1, draw the normal distribution curve. And then we plot our mean, which is the 110, and our x, which is the 112. And we are looking for the area to the right of our x value, which is 112. The next is we calculate. We use the formula for z value. This is our formula. But before that, we solve for our given percentage. We have 2.87%. We divide it by 100, so it will become decimal number. We have 0.0287. And then, we subtract it from 1.0000 since our area to be found is on the right side of our x value. So we subtract 1.0000 minus 0.0287 equals 0.9713. And now, we look for the closest value on the table. This is our table for cumulative standard normal distribution, and our given value is 0.9713. We are looking for its corresponding value. That is our given. And now, its corresponding value is 1.90. Therefore, we knew that 0.9713 corresponds to 1.90 based on our table, and this will be our value for z. And next, we calculate. We use this formula and we substitute our given values. Now we have 1.90 equals 112 minus 110 all over sigma or standard deviation. But we are looking for standard deviation. So, we multiply both sides of sigma. Then we cancel. Now we have 1.90 sigma equals 112 minus 110. Then we subtract. We have 1.90 sigma equals 2. Then we divide both sides of 1.90. Cancel. And now we have standard deviation equals 1.0526. Thank you for listening.